Properties of exponents. What does a to the n mean? That you use the a as a factor n times. So 2 to the 7th, you use the 2 as a factor 7 times. Remember, a factor is a number that you multiply. This rule, a to the m times a to the n equals a to the m plus n. If the bases are the same and you're multiplying, you just need to write the base once and add the exponents. This will give us 3 to the 3rd. This rule, a to the m to the n, gives you a to the m times n. In other words, a power to a power, you multiply the power. 5 to the 2nd to the 4th is 5 to the 2nd times 4, 5 to the 8th. A to the nth times b to the nth. Notice the bases are different. You keep them both. You multiply them and raise them to the n. You write the n one time. So 2 to the 3rd times 4 to the 3rd is 2 times 4 to the 3rd, which is 8 to the 3rd. Write with only one exponent. So 2 to the 6th times 8 to the 5th times 16 to the 3rd. You could change the 8 into 2 to the 3rd and the 16 to 2 to the 4th. Why would you want to do that? So you could have all the bases the same. Then simplify here. 3 times 5 is 15. 4 times 3 is 12. Now that you have the same base and you're multiplying, just write the base once and add the powers, which will give you 2 to the 33. This is partial product algorithm, 12 times 4. So give the 1 its place, which is a tens, and the 2 and the 4 its place, which are the ones. Then multiply the way you always do. The reason we have a 10 here is that this one is in the tens position, so it's worth 10. Then this is 4 times 2 is 8, and then give a row to each multiplication. 4 times 10 is 40, give a row to that multiplication. Add these results and you get a 48. The lattice multiplication for 14 times 23 uses the lattice. That figure is the lattice. So you put the 14 up on the top and the 23 on the side. Each multiplication is going to use one of these squares. So the 4 times 2 times 4 is going to use this square. 2 times 1 is going to use this square. 3 times 4 is going to use this square. So 2 times 4 is 8. So you put the 8 and 0 carry. 2 times 1 is 2 and nothing to carry. 3 times 4 is 12. Here's the 12. Now you use these diagonals that you see here to know what you're going to combine. There's only a 2 here, so you drop it. Then you combine these by adding 8 plus 1 plus 3 is 12. So here's the 2. And that carry of 1, you give it to this 2. So 2 plus 1 is 3. So it's like adding what you have in these diagonals. Then you read the outside, and 14 times 23 would be 322.